In this video, we are going to use Excel to conduct a regression analysis on drinks per month as a dependent variable, age as the first delinquent offense, and marijuana use per month as the independent variables. Okay. Besides the model, we also need to explain the R-square of the model, the slope coefficient for each independent variable, and the significance, or we call them the p-value, for each independent variable. So to do that, in the Excel, you may need to reorganize the variable a little bit for the selection of the variable in the regression analysis. Okay, so let's just take a look at that. So our dependent variable will be drinks per month. Where is the drinks per month? I'm going to make it easier. I'm going to cut it here. Drinks per month. Okay. For the independent variable, we have age at the first delinquent offense, and we also want to use the marijuana per month. Okay. For easy selection, we're just going to put those three variables together. So let me insert, so I can cut and paste. So now I have the dependent variable drinks per month here, and also independent variables age at the first delinquent offense, and the marijuana use per month here. Okay, for the easy selection. Okay. To do this regression analysis, we're going to click data analysis. I'm going to select regression. Click OK. Now it asks us to put a y in the formula. Y is a dependent variable, so which is the drinks per month. Make sure we select the label as well. Labels. Okay. For the x range, we are going to select all three independent variables: age at the first delinquents, and the marijuana use. Here, we also select the labels. Okay. The rest will be the default, and click OK. Adjust this table so easy to read. Okay. Now I'm going to write down something that we need to answer the following questions besides just the model. We already have the model here in this table. Okay, and then we're just going to interpret the R-square, the coefficient, and the significance. Okay, let's start with the R-square. So the R-square here, we have the R-square, or it's just R-square, 0.40, or like 0.405. Okay, what does this mean? This means that about the 40%, the 40.5% of the variance in the dependent variable, which is the drinks per month, right? We use the drinks per month as a dependent variable, can be explained or interpreted by the independent variables. We have three independent variables: age at the first delinquent offenses, and marijuana use per month. Okay, which is good. Now, the question did not really ask you about the F-test. So, but we will also explain a little bit about this F-test. Okay, so the F-test, which is the second table, test about the model that has no independent variable, and compared to the model that has independent variables, and whether the model has independent variables is better than the model that has nothing at all, just a dependent variable. Okay, so the null hypothesis will be there is no difference, and we can see the p-value for this F-test is 0.03, and we always know that our traditional cut point 0.05. So if this significance is less than 0.05, we have to reject the null hypothesis, right? So which basically means that this model that has independent variables is better than the model that has nothing. Okay, so the f-test, since the p-value is less than 0.05, which p-value is the p-value is less than 0.05, so we know that the model with independent variables is significantly better than the model with no independent variables, which basically means that when we're doing this regression, we're doing some meaningful stuff. Okay, we are not doing anything, we're just doing some meaningful stuff that we can use those independent variables to explain or interpret, or even we call them to predict the dependent variables. Okay, now the question asks you interpret the coefficient for each dependent variable and significance of each dependent variable. So let's go to the age. So age, the coefficient of the age is 0.97. Okay, so when we interpret, we have at least like two different ways to interpret. Okay, so first thing we can say, as 1 unit increases in age, about 0.97 units increase in what is our dependent variable? Drinks per month. Okay, so it's almost like when you are getting older by 1 year, you are more likely to drink one more drink per month. Okay, we also have a second way to say that is something you always see in the paper, actual academic paper, is that we don't really care about the coefficient, but we do really care about the directions. Okay, so this is basically either one is like, for example, age is positively related to drinks per month. The simple way to say that. Okay, so when you're getting old, you are more likely to drink more. Okay, and also we needed to explain the significance, which is a p-value, to see if this is significantly true or not. Okay, so we are going to look at the t, and most important, we are looking at the p-value for that one. Okay, so the p-value of age is 0.33, which is larger than 0.05. So if it's larger than 0.05, the answer is that we cannot reject the non-hypothesis. We have to accept the non-hypothesis. Okay, the non-hypothesis means you only suggest that age or this independent variable is not a significant variable. So since the p-value is larger than 0.05, age is not a significant predictor, or sometimes we call it a factor in this model. Okay, so even though we see that the data suggests, or the results suggest, is 1 unit increases in age, it look like another 1 unit increases in drinks per month, but this increase is not a significant increase. Okay, so in other words, here we say age is not a significant predictor in this model, which basically means in reality, or in the academic paper, age has nothing to do with drinks per month, technically, or statistically has nothing to do with drinks per month. Okay, now similar, we can do the second one, age at the first delinquent offense. Okay, so when we take a look at as the same thing, we see that this is a negative one. Okay, so when we say as 1 unit increases in age at the first delinquent offense, about 1.5 units will decrease in drinks per month. Okay, it's actually if you commit crime at an early age, the earlier the age is, the less likely you are going to drink, or less drinks you are going to drink for every month, which, well, it doesn't really make any sense or not, right? And also second, or we can say age at the first delinquent offense is negatively related to drinks per month. Okay. However, if we take a look at the p-value, age the first delinquent offense, when we look at the p-value, the p-value is 0.16, right? Which is larger than 0.05. So again, this is similar to the age we just tested. Okay, it's larger than the 0.05, so we cannot reject the null hypothesis. We have to accept the null hypothesis, which basically means that age at the first delinquent offense is not a significant predictor, or we call them factor, in this model. In practice, we say that age at the first delinquent offense has nothing to do with the drinks per month. Okay, so let's take a look at the last independent variable, which is marijuana use per month. Okay, in the last independent variables, we also take a look at the slope, the coefficient, and its direction. Okay, which is the 0.41. Okay, so as 1 unit increases in marijuana per month, about 0.42 unit. Okay, I typed this wrong, unit. Okay, about 1.5 units increases in drinks per month. Okay, about 0.42 units increase in drinks per month. Okay, now this is a positive relation, right? So marijuana per month is positively related to drinks per month. Okay, now is this relationship significant? Let's take a look at the p-value. It's here. Okay, so the p-value of marijuana per month, okay, is 0.039. Okay, so which we have a good news is that it's less than 0.05. So if it's less than 0.05, we have to reject the null hypothesis, right? We have to accept the alternative hypothesis. That means this variable, this independent variable, marijuana use per month, is a significant variable or factor or predictor in this model. Okay, and so that basically means in practice, among those three, age at the first delinquent offense, and marijuana use per month, only marijuana use per month is a significant predictor for drinks per month. Okay, although the other two, you will see that there are coefficients for two of them, but they are not a significant predictor based on the p-value we just see. So based on the p-value, the only thing that matters in this model, is a marijuana use per month. Okay, so for the whole conclusion is that based on our model, we find out that marijuana use per month is a significant variable predictor factor in explaining or predicting the dependent variable, which is drinks per month. The age at the first delinquent offense are not. That's the conclusion. Okay, that's it.